This episode, we're going to explore the world of the Calvin-Benson cycle. As you may know, this is part of the heterotrophic metabolic pathway. This reaction is known as the citric acid cycle, where we are going to utilize carbon dioxide, ATP, and NADPH to make glucose. We won't be needing any light for this cycle, so we're going to use some of that energy we made with the light energy from the sun to get this process going. Okay, let's begin. First, we're going to take some of this Rubisco blue right here, just like that, and also some of this carbon dioxide black, but not too much, just a little bit. And from here, we're going to use this to catalyze the carboxylation of ribulose 1-bisphosphate, 5-bisphosphate. But why don't we go ahead and add some phosporibulose kinase red? See, we want to be sure that we make the ribulose 1,5-bisphosphate happy and phosphorylate him so that he makes us the 2,3-phosphoglycerates we need to continue. There, aren't those 3 phosphoglycerates just fantastic? You know what though? I think this happy little 3-phosphoglycerate here wants to go live in the cytoplasm to become part of the central metabolic pathway. For the next part here, let's mix some of this 3-phosphoglycerate with some phosphoglycerate kinase. Bring it in right over here, right from the side. Now, you'll see that the ATP changes here from ATP to ADP, just like that. There we are. That looks like a happy little molecule right there. I think in this world, we need to reduce this one leftover 3-biphosphoglycerate down by adding some NADPH white, just like that. And that'll give us a nice glyceraldehyde 3-phosphate here, and we'll have the reduced NADPH over here, which is now NADP along with an inorganic phosphate. We've almost got a complete cycle, but Mr. Squirrel and I are going to add a few things to make it complete. I think this is where we're going to have a lot going on. It's a bit crowded, but all the enzymes will have their happy little places and wonderful things to do. Let's go to the palette and mix those enzymes in there. We're going to use some of this enzyme red right here to convert this glyceraldehyde 3-phosphate to dihydroxyacetone phosphate. There, that's a great looking molecule, but let's mix another yellow enzyme with the dihydroxyacetone to make us a happy little fructose 6-phosphate. Now we can do a couple of things with this fructose 6-phosphate. We can add some different enzymes and convert it to glucose, or what I think I'm going to do here is add a different red enzyme to the dihydroxyacetone and make us a really nice cetoheptulose 7-biphosphate. We'll call him SPB for short. But I think SPB is feeling a little crowded, so let's dephosphorylate him with some biphosphatase to make him a cetoheptulose 7-phosphate, or S7P for short. There we go. This is really looking like a happy little world here. Let's finish this up with some rearranging reactions to synthesize some xylulose 5-phosphate and ribose 5-phosphate. Isn't this fun? The last thing we'll do here is isomerize the molecules we just made with some more red enzymes to give us happy ribulose 1,5-phosphate that we can use again later in the cycle. And there we have it, the beautiful world of the Calvin-Benson cycle. Thank you for joining me today. Here is our final product, and as always, I hope you enjoyed my easy to follow, simple instruction.